derivatives. Now, I have been promising to talk about this for some time, and now I'm going to start the big time discussion. And this is going to take more than one video, so don't think that, well, gee, I watched this one video about derivatives, I understand all of it. No, not hardly, okay? So, just because I present a certain amount of material in this particular video does not mean you understand everything about a derivative, because you really don't, alright? Derivatives, in their most basic term, is deriving some kind of a number out of another number. Okay, so you're going to extrapolate a number out of a number or even an equation. Okay, you're going to take a particular number out of an equation or a particular number out of another number. Okay. All right. To give you an idea about a derivative, think of this. Okay. You have, say, a 4x4 car. And really, that's not so much a car, but 4x4 Jeep would be more like it. Okay, it's a big, heavy, super, think of like those Hummer-type cars. Okay, let's just think of a Hummer here, alright? It's way up on a hill. Now, it starts to roll down the hill. Okay, just imagine it's starting to roll down the hill. Now, let's say it's only moving at 3 feet an hour. It'd be really slow. Okay? Now, at 3 feet an hour, if you did not want to get trampled by this Hummer, all you'd have to do is step out of the way. Sure, you can watch the whole thing come down until it reaches a certain point, and then you can just step out of the way real quick. You never get injured. But let's say it wasn't going 3 feet an hour. Let's say it was going at 60 miles an hour. Now that's a different subject. You see that Hummer going straight at you at 60 miles an hour, you might want to jump out of the way rather than just simply walk out of the way. The difference between going 3 feet an hour down a hill and 60 miles an hour down a hill is where we started having the derivatives. Let me tell you something. Life and death depend on how fast that thing's coming down the hill. Because you may only have a second or two to jump out of the way if it's going 60 miles an hour, but if it's going 3 feet an hour, you can sit there and watch it all day. And that's what we're talking about in derivatives. It's the same thing with a bullet. Let me tell you something. If somebody takes a bullet and just throws it at your face, you're probably going to survive. You know, it might sting a little, but you're probably going to survive. But if they shoot it out of a pistol, you may not make it. And that's what we're talking about. It's the difference between whether you can watch something and go, ha ha, yes, you're dumb. You threw a bullet at me. Gee, like that's going to hurt. Might sting a little, might leave a little bruise, but you'll be all right. And somebody pulling a .357 and shooting it. Now, that could be a big different story. And that's why we have derivatives. All right. The first thing I want to tell you people is that any object dropped near the earth, and we're talking about, let's say you're less than 5,000 feet in the air, okay, say you're in a building, you're less than 5,000 feet from the ground. If you drop an object, it's going to move at approximately 32 feet per second. Newton proved this, and you can go through all the wonderful stuff to see this truth for yourself, but just take my word for it. If you have an object, you start dropping it, and you're near the earth, it's going to drop at about 32 feet per second. Okay? Now, we have this equation here called S equals 16t squared. T in this case represents time, and the S here is commonly used to represent distance because the word spatium, which S is the beginning letter of, spatium is the Latin term for space, room, public square, or even a distance between 2 points. That's why they use it. Alright. Now, let's say you go up a certain number of floors of a building and you take a golf ball and you start dropping it, okay? And we're going to use the equation S equals T squared right here. We're going to use this equation. And you start dropping the ball. After 1 second, the ball is going to fall 16 feet. After 2 seconds, it's going to fall 64 feet. 3 seconds, it's 144 feet. 4 seconds, 256. 5 seconds, 400 feet. And 6 seconds later, it's going to fall a whopping 576 feet. All these numbers are feet. Okay? What you don't realize is that that's kind of an average speed. You know that during a period of 1 second, remember there are tenths of a second, hundredths of a second, thousandths of a second. So during the period of 1 second, the ball has dropped 16 feet. And the period of 2 seconds, 64 feet, so on and so forth. But that's a period of 1 second. That is not exactly at 1 second. We can find the average speed of an automobile. If we have an automobile and it travels 30 miles an hour, you divide the 30 miles by 1 hour and you get an average speed. So on and so forth, okay? If you have a car that's traveling 30 miles an hour, you've traveled for 2 hours, you've traveled 60 miles, you can kind of get an average. So it goes on and on, but you can get an average speed, all right? But we don't want an average speed in this case. We want to know what happens instantly, because when the golf ball hits the ground, let's say it's not a golf ball this time, let's say it's an egg. Well, let me tell you something. If an egg hits the ground at, say, 1/10 of a mile an hour, it may actually survive the impact. But if it starts traveling any faster, it'll crack open and boom. And let me tell you something, glass is the same way. If glass gets enough speed going over a certain distance, boom, it's going to shatter. So on and so forth. So, distance and speed directly correlate with whether something survives the impact of a fall or it doesn't. Same way in car crashes. Let me tell you something. If you have a automobile accident at 5 miles an hour, not very much damage is going to be done to either one of the cars. You have the same accident at 60 miles an hour, that's a different story. And if you've watched my car wreck videos, you can tell immediately that having a wreck at a higher speed can cause some real significant damage. Alright, now this is part 1 of derivatives. There will be a part 2, and there'll be a lot more parts than that. I will tell you more in a future video, so stay tuned.